Hi, we're going to have a look at how to deal with some complex fractions, and in this case we're going to be looking at a fraction which looks like this. As you can see, it's not the simplest of fractions, but as we work through it, you'll see we just deal with things a step at a time. So let's take the first step, which is to multiply top and bottom here by this denominator there, and top and bottom here with that denominator there. Now, why do we do that? Well, it's the technique that we use in all fraction problems to get the denominators the same. As you can see, we now have on the bottom here x plus 2 times x minus 2 and x plus 2 times x minus 2 there. So we're going to end up with the same denominator, and that means that we can then carry out functions like adding or subtracting. Let's see what that takes us. So we've multiplied out the two brackets at the bottom here. X times x gives x squared. 2 times x gives 2x, x times minus 2 gives minus 2x, and plus 2 times minus 2 gives 4. And it's exactly the same with the other fraction because we've basically got the same two brackets here. And that can then be simplified down to x squared minus 4, because the 2x and the minus 2x in the middle here cancel each other out. Now I'm going to pause in doing this here to remind you about a form of factorisation that's called the difference of two squares. If we see two squares like this, x squared and 4, which is a square number, with a minus between them, we have a difference, which is what a minus means, of two squares. When we have that, we can split into brackets with x plus 2 and x minus 2. In other words, the square root of this and the square root of that. X is the square root of x squared and 2 is the square root of 4. Let's have a look at a couple of examples of that. If I've got x squared minus 9, I can just split it into x plus 3 times x minus 3. Square root of x, square root of 9 in both brackets. Same with the x squared minus 36, both square numbers, so we can split them into two brackets, x plus 6 and x minus 6. Now, going back to the problem, we can see that we have the top now multiplied out. X times x gives x squared. Minus 1 times x gives minus x, minus 2 times x gives minus 2x, and minus 1 times minus 2 gives plus 2. On this side we've got x times x gives x squared, 1 times x gives x, 2 times x gives 2x, and 1 times 2 gives 2. We then move on and have a look at how this simplifies down. We add together the like terms, so our minus x and our minus 2x becomes minus 3x. Our x and our 2x becomes plus 3x, and so we've simplified that problem down quite a bit. The next step is to then get them into the same fraction. Now, that was why at the very beginning we made the denominators the same, so that we could actually combine them together in the one fraction. Now notice that this minus sign here applies to the whole of this expression here, and therefore when we combine it into one fraction, we need to take account of that by putting brackets around the whole of this expression. What effect does that have? Well, you see that when we take the minus into the bracket, we have to apply it to each term. So we've got minus x squared, we've then got minus 3x, and then minus 2. The next step, of course, is to combine terms of the same type. So we've got x squared, take away x squared, that gives us nothing. We've got 2 minus 2, so that cancels out as well. And we've got minus 3x giving us our minus 6x. And that is effectively the problem simplified. Now you'll see our final fraction is a single fraction, and it's much simpler than what we started with. Thank you for listening.